Hi students, welcome back to our Python class. So let us see the same topic, that is scope of variables. Continuation we will continue here. That is case 3 we need to discuss. And case 3, no, we have same variable name if it is going to be used in local scope as well as in global scope, what we need to do. So actually when the same variable name is going to be used in local scope and also in global scope, so which is used currently, which environment currently that variable name is referring. So if that variable name is assigned with some value using an assignment statement or assignment operator, so the current environment value only will be taken by that variable. So that is the thing happened here. Let us see with some example also here. Okay, so if inside a function you assign a value to a name or a variable which is already there in the higher level scope, the Python won't use the higher scope variable because it is an assignment statement. An assignment statement creates a variable by default in the current environment. So if you see the example, you will understand. That is, for example, consider the following code. Define state1. State1 is the function name. Tigers is equal to 15. Print tigers. So these two statements, no, tigers is equal to 15, it's an assignment statement, and print tiger. These two are belongs to function state1. And next, if you look at this, tigers is equal to 95, print tigers, state1, print tigers. So here tigers is equal to 95, print tigers. Here this tigers is equal to 95, print tigers related to main Python program. So main segment of the program, that is top level statement. So this when this program is getting executed, first tigers is equal to 95, print tigers is getting printed. Okay, 95 is getting printed. Next state1 is called, this is function call. So immediately it will go to the flow of execution, or the order of execution will be transferred to state1 function inside the first statement, that is tigers is equal to 15. Now tiger is referring the value 15. Then the same 15 is going to be printed here after that value getting printed, no, so it comes to again the main part. So again it prints the tiger. So currently which environment this tiger is referring now? Global environment. So global variable tiger is referring the value 95 now. So 95 is printed. So this statement, that is the state1 function inside, where we have used tigers 15 statement, no, tigers is equal to 15, will create a local variable with the name tigers as it is an assignment statement. It won't refer to tigers of main program. So in the main program, tigers value is not going to be referred by this print tigers in the local part. Okay. So here you can look at here in this picture. So global environment tigers is assigned with 95, and local environment state1 inside tigers, same tigers is assigned with 15. So the result of print statement inside state1 function, thus the value of local tigers is getting printed. Local tiger value is getting printed. Now the result of print statement inside the main program, thus the value of global tigers is printed. That means a local variable created with the same name as that of global variable, it hides the global variable. As in the above code, local variable tigers hides the global variable tigers in the function state1. Okay, so it is not printing the value 95 here. Now, what if you want to use the global variable inside the local scope? So if you want to use the global variable tiger inside the local scope, what you need to do? You need to write this tigers in a global, as a global. Okay, so global tigers, like that you need to write one statement. If you want to use the value of already created global variable inside the local function without modifying it, okay, then simply use it. Okay, Python will use LEGB rule and reach to this variable. So it will use that variable what? Rule. Local environment, and then enclosing environment, and then global part, and then built-in part. So like that it will use that rule in order to reach that variable. Okay. But if you want to assign some value to the global variable without creating any local variable, then what to do? If you want to assign some value to the global variable without creating any local variable, then what you need to do, this is because if you assign any value to the name, Python will create a local variable by the same name. For this kind of problem, Python makes available global statement. So Python will be using here as global statement. So global statement is a declaration which holds for the entire current block. So it is going to be used for the entire current code block fully. That global statement is going to be used. means that the listed identifiers are part of the global namespace or global environment. So if you define any variable along with that name global, keyword global, so it is means that it's a part of global namespace or global environment. To tell a function that for a particular name, okay, to tell a function that for a particular name, do not create a local variable but use global variable instead. Okay, instead of global variable, use it as do not create a local variable but use it as global variable instead. You need to write global variable name. So if you want to use the tigers as a global variable, you need to write the statement like this. Okay, so this is an indication not to create a local variable with the name tigers, rather use global variable tigers. Okay, so now the global environment is not assigned with 95, it is assigned with here 15. Okay, so local state, it's not having any value, and this is going to be used as a global one. So this tigers 15 is going to be used as a global variable here. Okay, so local variable, you are going to make it as a global variable. So for example, in the above code, if you want a function state1 to work with the global variable tigers, you need to add a global statement for tigers variable to it as shown below. So like this, you need to add global statement before the tigers. Okay, and then so when this is printed, the above program will give the output as what? First it will print 95. So because main part is getting executed. When the function call starts, now here this tiger is assigned as global. Okay, so now automatically the tiger will be assigned with 15. 15 is getting printed. So even after the this state one got over, no, state one function got over, all the statements, if it is getting executed, then when it comes to main part of the program, this tigers, that is tigers 15 only, is going to be referred in the global environment also. Now 95 is going to be ignored. Okay, so the result of print statement inside the main program is the value of global tigers, which is 15 only, now is going to be printed. So here 15 is modified, that is modified as global, so that second statement also 15 is printed here. So the global statement cannot be reverted in a program run. So let us see that part also. Once a variable is declared in the declared global in a function, you cannot undo the statements. Once we have declared like that, we cannot undo it. Okay, we cannot undo it. That is after a global statement, the function will always refer to the global variable only. Okay, and the local variable cannot be created of the same name. So local variable we cannot create of the same name. Once we have defined as global, we cannot create the same name for a local variable. So but for good programming practice, that use of global statement is always discouraged. So never use that global statement whenever you go for any programming. Okay, Python programming, if you are typing any programming codes, never use this global statement. Okay, it is always discouraged, as with this programmers tend to lose the control over the variables and their scopes. The programmers may lose their control over the variables and also their scopes. So for that reason only, it is not encouraged to use the global statement. It is going to be discouraged. So never use this global statement when you are doing a good programming. Okay, so the global statement cannot be reverted, that is cannot be undone in a program run. Okay, one should avoid using global statement in the Python program. Although global variables can be accessed through a local scope. See here in this previous example, global variables are going to be accessed. See, this is the global variable, are going to be accessed in the local scope also. Okay, it is not good programming practice. So keep global variables as global and local variables as local. Now next one is progress in Python, that is calling functions, argument types, and scope of variables. Okay. So immutable and immutable properties of past data objects. So when you are passing some value, some data objects, some values, no, from main part to the subprogram, that is function. So whether it is a mutable or immutable, the properties we will check it here. Okay, so mutable means what will happen, whether the value will be changed in memory space or whether it will not be changed in memory location. That variable, no, either formal argument or actual argument, which memory address or where it is referring. So everything we will see here under this mutable and immutable properties of past data objects, because Whenever you pass any data or value to the main part to subprogram or function, depending upon the data type, we have categorized as mutable data types and immutable data types. So according to the data type of that variable, what data you are assigning, data object you are assigning to the variable, according to that the variable will take either mutable or immutable property. Okay, so lists and dictionaries are mutable data types, mutable data objects. Lists values are mutable data objects values, and other data types like integer, float and all comes under immutable properties. Okay, it will follow immutable properties. That means whatever value we are changing, that value is not going to be affected in the memory address. In case of immutable, we cannot change the value in that same address, so the new value will take the new address only. So that is only immutable properties uh, property. And mutable means whatever value we are updating for the list, okay, or dictionary, that is going to be affected in the same address itself. Okay, same address itself, new value is going to be updated. So now you know how you can pass the values to a function and how a function return a value to its caller. Okay, so now we have understood how the function is called and how the function is return its value to the caller. But here it is important to recall following things about the variables. So when you are passing some actual arguments to formal arguments, you need to understand something, that is Python variables are not storage containers. Instead, they are memory references. Okay, so only it is referring the memory address. So from that address, we can take the value. So it is not like a storage container. We should not say it is a storage container. Okay, even if you have learned Python variable is otherwise called as a named variable, sorry, a storage container, or it's like a container. It's like a container only, but we should not say it's like a storage container only. So it's a memory reference. So it is used as memory reference. They refer to the memory address where the value is stored. So in which place the value is stored, that address is going to be referred by that variable. Okay, and then second thing what you need to remember here is depending upon the mutability and immutability of its data type. Okay, now only I have said lists and dictionaries are mutable data types. Other than that, others, all the other data types are immutable data types. A variable behaves differently. Okay, and that is if a variable is referring to an immutable type, then any change in its value will also change the memory address it's referring to. But if a variable is referring to mutable type, then any change in the value of the mutable type will not change the memory address of the variable. So memory address is going to be changed in the case of immutable, and whenever we change a new value, memory address is not going to be changed. The value will be affected in the same memory address only. Okay, so then another important thing to know here is that scope rules apply to the identifiers, that is variables, or the name labels, not on the values. Okay, so scope rules are going to be applied to the identifiers or the variables only, name labels only, or variables only. It is not the scope rules are not going to be applied on the values. For example, if you pass an argument a with the value 5 to a function that receives it's in a parameter b. Okay, in a parameter b means what? In a function b is used, the b variable is used as a parameter. Then that 5 is a is assigned with value 5, that is actual argument. When it is passed, from the main part to the function, then both a and b will refer to the same value 5 in a data space, even with different scopes. They may refer to the same data in the data space depending upon the mutability, but you can use name b only inside the called function, because that is belongs to one function only, one subprogram. B is belongs to one subprogram, B variable, and not in the calling function. So in the calling function, we cannot use the B. This will become clearer to you when we discuss the mutability with respect to arguments and parameters. Okay, so arguments means what? The main program, which argument we are using, the which variable we are using, that is known as argument. That is in the main program. A is used and B is used in the subprogram, that is called as parameter. Okay, so in a called function, whatever arguments we are using, variables we are using, that is known as parameters, formal parameters. Actual parameters means the value which is passed from the main program. Okay, so integer literals, integer it's a immutable data type only. So integer literals, constants, that is literals means what? Constant values. So integer literals are stored at some predefined locations. Okay. So for example, if you consider here this square node is having a red color number that is known as values. Okay, 0, 1, 2, 3, 4, 5, 6 and all values. And the top part of the square is having on 6-digit number that is known as memory address. Okay, number of references, memory address here. So 148,200 is having the value 0, and then like that 16 is having the value 1, 32 is having the value 2, 48. So if you see here 16 bits are added here for every address. Okay, and number of references, for example, here variable here we have a code. So left side you just look at here, code is written list 1 is equal to, inside the square bracket we have given the value 1 comma 3, that is list 1 of 0 is referring the value 1 and value 3. Okay, so value 1 is stored in which address? 216. So it's pointed here. See this arrow? It is going and pointing here the value 1, that is 216 is referred. And the list one of 1 is referring the value 3, that is referring the address 248. So now you have 3 is referred by list 1 and 1 is also referred by list 1, and variable is equal to 1, where variable 1 is equal to 1. So 1 is referred how many times? 2 times this number of references made for this value 1, 1 for integer data type. So this variable 1 is there, no? See here, look at here. This variable 1 is there, no? This is integer data type variable. And this variable list 1 variable is there, no? List 1 is list data type variable. So which is mutable and which is immutable here? This variable 1 is the immutable data type, and list 1 is a mutable data type. So here this value 1 is referred. Okay, so the first two values are there, no? For list also 1 is there, variable also 1 is assigned. So 1 is referred by integer data type variable also and list data type variable also. So 2 times references are made here. Okay, so variable 1 stores the memory reference of integer value 1, that is 148216, as it is currently storing 1. Okay, so this address only is now holding the value 1. And list 1 has been allocated address 200 160. Okay, so has been allocated to the address 200 160, where it can store the memory references of its individual items. So in this place it is storing the memory addresses of individual items like 1, 3, the data items addresses now is going to be assigned here in this address. Okay, 200 160. Now, example, list 1 of 0 currently store here the memory reference of integer value 1, that is 148216, and list 1 of 1 stores the memory reference of integer value 3 at address 148248. Okay. Now, if you make the following changes to list 1 and variable 1, for example, now we need to check mutability and immutability. So which is mutable here? List only mutable. That means if you are changing list 1 of 0 to 3, so now list 1 of 0 will be affected with 3 only. Okay, so that means list 1 of 0 is referring what? 148216. This will be changed with 3 now. Okay, this 1 is now changed to 3. Now variable 1 is equal to variable 1 minus 1. So now variable will be referring to what? Variable will not be referring to 1 now. Okay, it is referring to 0 now. So variable will be referring to 148200. So the address of the memory address or memory reference of variable 1 will be now what? 148200. Okay, when we are changing the value of list 1 and variable 1, what will happen? Let us see this picture. Okay, so now if you make the changes, following changes, now variable 1 referring to the address 148200, and this list 1 of 0 and list 1 of 1 both are referring to 3 only, because already we have in the list 1 comma 3. Now this one list 1 of 0 only is going to be changed as, that is 1 is going to be changed as 3 now. So automatically both the values are 3 only in the list. Okay, so both are referring to same memory address, memory reference only. Okay, so now I think you are clear with mutable and immutable. So mutable means the value will be affected in the same place only. Okay, so 148248, now it's referring to same value 2 times the memory address is referred by this list. Okay, So this is the impact of mutability and immutability. Okay. So with this, we will stop this session. We will see next few topics related to this mutability and immutability in function call, and that is in calling function and in called function with some more examples in the next video. Until then, revise the previously taken videos. Thank you, students.